Thank you, Alex. Alex is the best. It's so much fun. He's taking the best 3D pictures, and I'm super excited to be here. Thank you for joining my talk. Functions 18, hashtag, build scalable APIs using GraphQL and Serverless. I hope you're having a fun day. There's still half of it left, and excited to be here. Cool. So I want you all to take a second and think about Twitter. And think about Twitter in terms of scale. So Twitter, as of maybe early this year, had 330 million users. And also, us collectively, we are creating 6,000 tweets per second, some of them with the functions 18 hashtag. That adds up to 350K tweets per minute, which in total is 200 billion tweets per year. That's amazing, right? How many of you are working in a company that's this kind of scale? That's huge. I see maybe a couple of hands there, but most of us are working on like mordable, no, that's not a word, sorry. Anyway, now let's think about the creators of Twitter. If they had an idea about what kind of scale they had to prepare for, and what if they froze and never created Twitter? That's me on every single startup idea I've ever had. And that's also the reason why I absolutely love serverless, because it enables me to build applications that basically can scale, and I don't have to think about that. I don't have to worry about what's the programming language that I'm using, what's the web server that I'm using, what's the hardware that I need, what's the provider that I'm using. I just have to code, and that's it. And that's great. And today we're going to look into how to build APIs using serverless with GraphQL. My name is Simona Cotin, and I work as a cloud developer advocate at Microsoft. I mainly focus on the web, and my goal is to help build great experiences for developers that are using the cloud. So if you have any questions about Azure or about JavaScript, about Angular, and of course serverless and GraphQL, do reach out on Twitter at Simona_Cotin. And then I'll be around the entire day. Maxime and I will also run a workshop towards the end of the day, so do join us there. Okay, cool. 2014. That was a cool year. That's the year when serverless started getting to life, and it was also towards probably beginning of 2015. That's when GraphQL was released. And it was released, by released I mean open sourced, at Facebook. The team had been using GraphQL, in fact, for about 3 years already. And the reason why they started using GraphQL and they built GraphQL was because they needed a data fetching API powerful enough to describe all of Facebook. That's kind of impressive, right? It's yet another application that has immense scale. So what does this all of Facebook mean? I took a screenshot of my timeline a while back, and just looking at this page and understanding what kind of data do we have to retrieve from here in order to display all this information. Well, on the left-hand side, we have information that's particular to my user. So things like what are the groups that I belong to, what are the events that I might want to attend, what's the link to my Messenger app. In the center, it's a list of posts that have been created by my friends, probably have been liked by my friends. And on the right-hand side, it's a list of friend suggestions, birthdays of my friends, their stories, and again, events. So that's a lot of data. And if we were to think from a REST perspective, how do we retrieve that data? How do we make sure that we can display all of this data on a single screen? Well, we would have a series of requests, right? Because everything in REST must be a resource. And you must uniquely identify certain resources, and everything has to be a hyperlink. So if you have an object that links to a different object, then that must be a separate request. That's one key characteristic of REST that we should implement whenever we're implementing REST APIs. So looking at the previous page, the requests that we are making are things like, give me the user information, so facebook.com user ID, give me the list of events, give me the list of friend suggestions, and maybe their birthdays. And diving deeper into the list of events, we would probably get an array with events that look like this. This is a JSON object that contains the name of the event that we're attending, the location, the organizer, thank you, Ahmad, the size of the event, the list of attendees, a lot of information, right? This is the typical information that you would get for an event. But if we look back at this page, we only need the number of events. We don't need all that information. So what are our options? Well, we could either overfetch information, so get all that information by default. And that means that we are kind of abusing a user's or a client's data. And that becomes even more important when they're using a phone. And even more important when they're using a phone and they're in a country where data costs a lot. So we're not only basically sending a lot of data to people, we are basically putting our hand in their pocket when we're doing that. And sometimes for certain people, that matters a lot. The other option that we have is adding a new endpoint. So creating a new endpoint that only returns the number of events that are suggested for a certain user. None of these two options is ideal. Overfetching, as I mentioned, basically means that we are sending more data to a client that they don't need. And adding a new endpoint means that we have to get at least two teams together. So we have to get the backend team together with the front-end team and let them work out how they're going to add that new endpoint and how they're going to use that new endpoint. So that's work. Okay, cool. We haven't made a decision on that. What about friend suggestions? If we were to maybe get the list of the suggested friends, we would probably request this kind of data. My name, well, actually, the suggested friend's name, last name, profile picture, and then a list of mutual friends. And REST says that because that list of mutual friends is a link to a different resource, then we have to make a new request that retrieves those mutual friends and information for that mutual friends, like name, company, role. But really what we needed here was both the first name and also the mutual friends. But now we need to make two different requests. We need to make a request with the suggested friend, and then we need to make a request for mutual friends. And that's two requests. That's not ideal either. And this is called underfetching, when we have to make multiple requests to be able to display valuable information. So now we are making two requests, and again, this is hitting the performance that our user is seeing. And if we combine this with the fact that we're requesting more data, so we are both displaying non-performant application that retrieves more data than they actually need. And the other option here is adding a new endpoint that retrieves all that data. It's not very REST-like, so it wouldn't be compliant with how REST should work. And you'd also have to have teams together work out how they're going to use that new endpoint. This is where GraphQL comes into play. GraphQL helps us with figuring out, well, not figuring out, it helps us with not having to do neither overfetching nor underfetching. GraphQL allows us to define exactly the data that we need to send to the client. And in fact, the client owns the request and the data that is receiving. So the client will say what kind of data it needs, and then the server will make sure that that's the data that's going to be sent. So if you look at this query, now the way we would make a request on your left-hand side, this is how you would make a request to GraphQL. You would use the query keyword, and then you would specify the data that you need. So we need to get information for the user with the ID 101. We only need their first name and last name, and we need the events. And the only field that I need to retrieve for those events is count, and that's it. That's all I need. And then for friend suggestions, I only need their name and the count of mutual friends. And with GraphQL, I can define that in a meaningful and declarative way, and that's great. And on the right-hand side, you can see the response to that query. And the response to that query is a JSON object that looks extremely similar to our request. And that's really intended because the client defines what data is being returned by the server. And that's key. That's very important. Fantastic. So we've seen kind of what GraphQL helps us with. Now what about serverless? When serverless started to exist, most of the times we were looking at a monolith application. Or if it wasn't a monolith, probably it was a series of microservices that would achieve a couple of things. And as we started looking at serverless, we started shyly implementing a couple of services using the serverless technology. So probably some of the tasks, the background tasks that we used to have implemented in batch jobs or something similar to that, things like data processing. Give me a file path, and I'll process all the files in that directory, and then I'll save that data in a database. That's the type of operations, or that's the type of functions that we would write when serverless just came out. Very, very separate from anything that was critical to our systems, anything that was client-facing. And that was the right way to do it, because serverless was very new. We didn't have the tools, we didn't have the content created, we didn't have the communities that we have now. Like, look around you, it's more than 300 people interested in the same topic. That's fantastic. I think serverless has come a huge way. So then as time was passing by and more content was being created and the tools have been built, we started being more brave and started implementing features that are client-facing. Things like maybe API endpoint, or things like maybe a notification, a newsletter subscription. That's something that we can add into our serverless belt. And probably today, this is how our application looks like for some of us, where you still have that small monolith or that small microservice, but then you have tons of functions outside that. And it's small little functions because we've learned how powerful serverless is and how creative it allows us to be. We have started writing functions for everything, and sooner than later, we actually figure out that we have no idea how many functions we have, and we have no idea where they are and what they do. And that's where GraphQL can help us as well. Because GraphQL, even though we say that GraphQL is a single endpoint, which is completely true, another thing that I find very useful in the case of GraphQL with serverless is that it allows us to define a contract where we aggregate all the information about all the endpoints that we have available in our application. And I think that's very valuable because this gives us some structure to our code base, and it gives us some structure to our project and what is being exposed to our clients. Does that sound like reasonable? Yeah? How many of you have been here where you have thousands of functions everywhere? Well, not thousands, okay, hundreds. There's this amazing guy, his name is Yan Chu. If you haven't read his stuff, he's fantastic. He's also working on a course, and he has this huge diagram with like literally hundreds of functions that he's connecting and he's running in parallel. And it's insane. It's crazy. Cool, so how do we get started? How do we get started with GraphQL and serverless? Well, GraphQL, we bring together the front-end team and the back-end team, and we start doing this thing called schema-driven behavior, where basically the client and the backend team will say, well, we need these operations because these are the clients that we're building. So we're building a mobile application, we're building a website, we're building like apps for all these clients, and we need data to be structured this way. And then the backend team will say, well, cool, I have these data sources and I have these REST APIs and services that I can use. Let's build a schema, and that will be the contract that's going to be used throughout the development cycle by both teams. And the greatest value here is that basically, for example, the front-end team will be able to take this schema that has been defined and immediately start developing against that. So it makes us productive instantly. One thing that's important about this schema is that it's strongly typed, and it defines all the operations that the backend will be exposing. And when I say strongly typed, I mean that we do use types. So GraphQL comes with scalar types, which are primitive types that we've seen in different strongly typed languages. Some of them are types like string or int or boolean, or even ID, which allows us to define a unique ID. You'll see towards the end that there's this exclamation mark right next to the type that we're using. That means that that field will be required when we're making a query or when we're retrieving data. And then the fact that this schema is strongly typed, it allows us to do static analysis of our queries. So on top of GraphQL, we have these tools that are called maybe Graphical or GraphQL Playground that allow us to introspect our schema and basically see the live documentation. But most importantly, it validates our query before we send it. So as you can see here, I'm trying to run a query on the GitHub API, and I'm not sending enough parameters. And this UI will notify me. It will tell me that I'm missing one of the fields. I highly recommend, if you haven't tried GraphQL before, just go ahead and check out GitHub's API. It's all written in GraphQL, and you'll be able to run queries there, and it will be super easy to just explore how intuitive the language is. This is how, if we were to create a schema and expose it on our backend, this is how it would look like. So I'm using this build schema helper function from the GraphQL package, and I'm defining the team type and some operations that are available on our API. And the way we define a new type is using the type keyword, and then we're giving it a name and curly brackets, and then we define the fields that are available on that particular type. And their type. ID, which is mandatory, name, which is string, and points, which is int. And then if we wanted to have a nested type, we could define a people type, which would then, in our team, could contain a list of people. And that's how we define an array. We basically add square brackets, and then we set the type name. So I mentioned also operations. That was just to give you an idea of how a type looks like and how do you define one. The operations that we can run on GraphQL are 3 different ones. The first one is queries. And this is basically your typical read operation that you would have in REST. That's the get operation. We're reading data using queries. And this is a simple query that we can run. It has the type query, which is a predefined type in GraphQL. And then we define a name for that query, which in this case is teams, and the return type of this query, which in this case is an array of team. So this is how we would query an API for a list of teams. And in the client, this is how we would execute that query. So we need to use the query keyword, and we need to filter down the operation that we're executing, that is teams, and the fields that we want to return for each of the elements, that is name and points. And then on the right-hand side, you can see the data that is being returned by our API. So remember, query is your get operation. We're reading data using queries. What about delete, post, and put? That would be your mutation in GraphQL. So we are mutating data. And the way we define that is using the type mutation. And we give a name to that operation, and maybe we want to, in this case, we want to update the number of points for a team, and we want to return a team. This is how we would query it from the client side, and that's the data that we would get returned. But remember, we've only defined those operations. We haven't implemented them. So it's almost like an interface. In the schema, we specify what kind of operations we support, but then in this thing called resolvers, we actually go ahead and implement those operations. So in this case, you will see that I am retrieving data from 2 endpoints, which are functions as well. And this is how the schema looks like. So we have a client that queries a GraphQL endpoint, that hits a GraphQL endpoint, and then that GraphQL endpoint actually calls 2 different functions, which reads data from Cosmos DB. And it doesn't have to be that way. We can actually read data directly from GraphQL from a database, but most of the times we're actually going to add a cache in between our database and our function or our GraphQL endpoint, because we want to make sure that we're being performant about the way we're querying data. And because GraphQL doesn't make sense when all the time when you have only one client, we're probably going to have both a browser and a mobile, a phone and a tablet, everything. Okay, cool. So what about serverless? We've talked about GraphQL, but what about serverless? Well, the best news is that we can actually host an entire GraphQL endpoint in a single function, And this is how you would do it. This is an example of an Azure function, but you probably can do the same with any other cloud provider, where basically we are using the GraphQL package, the JavaScript version of it, and we are running this GraphQL function that gets method that gets as a parameter the schema that you've seen earlier. The query will be sent as part of the request, and then we can also get variables and operations. Those are things that will make much more sense when you will see graphical. And then we are returning the response that's being returned by the GraphQL method. So that's it. This is how you would host a GraphQL endpoint in your function. It's a couple of lines of code. And the best practice says that a GraphQL endpoint is being served at a GraphQL URL path. So the way to do that with Azure Functions is basically to define in your configuration file, to define a route and override the existing name of the function with this particular route, which in our case is GraphQL. So now we have a GraphQL endpoint that's being served at the GraphQL URL path, and it's awesome. What about graphical? I've mentioned it. It's an IDE for inspecting our schema and for seeing documentation for our schema and also for running queries and mutations. which looks like this. I highly recommend you check out the GitHub one. It's built in React. So it's a set of React components that makes a fetch request to our GraphQL endpoint, which means that it's static. So I have an index.html file that I can deploy somewhere serverless in a static storage. And once I've done that, I actually want to be able to deploy it under the graphical URL path, because that's also a best practice, where your graphical and GraphQL endpoints are under the same URL path. And the way I do that is using proxies. And proxies is a very thin API layer on top of our function app or on top of a collection of function apps. It basically allows us to use the same URL for different function apps and for different URLs. So in this case, I'm going to define, this is a JSON file that sits along to your function app, and I have a list of proxies that matches a method, and it matches a route, and then it redirects the request to a URL that I can give it. Two more cool things you can do with proxies. You can also mock your data. So instead of returning a backend URI, if that's not implemented, you can return right there response that the front end will be able to use. And also, if you're running this alongside the same function app, you won't run into CORS issues anymore, CORS issues. Fantastic. So we have a GraphQL endpoint. We have graphical. Both of them are hosted in a serverless environment. That looks great. But it's never that easy with tech, right? Because we have evil people and we have complexity. And this is an amazing blog post written by Max Stoiber on his journey to fix some security issues in his product while using GraphQL. And one of the issues that we might encounter with GraphQL, or one of the things that allows us to run into issues with GraphQL, is nested queries. And the reason why those can be problematic is because if you look at that simple query and then you expand on it, it becomes very complex. So imagine now we are retrieving a list of teams that can be like 100 teams, and then the people on that team, for each team in those 100, you might have 20 people, and then they might have a list of friends, which have a list of shared events. And if you add up all of that, that's going to be a lot of load on your database, that's going to be a lot of load on your server, a lot of complex data that's going to be passed down the network and will have to be parsed on the client as well. So we have to be aware of these use cases and make sure that we have the resources to handle them. But that's not the only bad use case. We could have evil people that might run into these recursive queries that will basically turn into a denial of service attack. And we have to make sure that we deal with these cases. And what we can do is limit the allowed depth of the queries that can be executed, or the nesting that we can do. And there's packages that can help us with that. GraphQL depth limit is one of them. And the way we would do that, in our GraphQL configuration, we would define a validation rule that defines 10 as the maximum level of nested queries. And then if that's being exceeded, then we're going to return an error message to the client. Another use case, imagine we start with 2 teams, right? But as with everything, things expand, and we might have 2 million teams. And we want to start paginating that data. And most of the people will ask for reasonable data. But you'll always have unreasonable people or clients that will ask for a gazillion objects. And that's not great, because we'll run into the same issue. So what we're supposed to do here is limit the allowed amount of items that someone can retrieve. And the way we can do that is very similar to the previous example where we define a maximum allowed, and then we are comparing the number of items requested to the maximum, and we're returning an exception if that's not correct. Another use case that I'm going to let all of you look into is query complexity. There's packages that can help us with that, but basically the idea is that every single field will have an assigned weight. We're going to sum that up, and based on the complexity, we're going to not answer that query. We're going to return an error. The one thing that I want to leave you with, which I'm still working out in my mind, but I think it kind of makes sense. I think GraphQL is serverless for your data. And I'm going to let that sink in for a second. GraphQL is serverless for your data. Because serverless auto-scales. With GraphQL, we can ask for one field up to a gazillion fields. And GraphQL allows us to do that, to combine all the data that we want to retrieve. And that's what auto-scaling is, right? With serverless, we pay as we go. We only pay for the resources that we're using. With GraphQL, we can only request the data that we need, which means that on the network, we're not going to receive all that data, all those idle resources, all those fields that are not required. We're only going to get the data that we have required and that we need. So our user, our client, is only going to pay for the data that they have requested, not for what the server has decided that it's what they want to define. React to events, I'm not sure about this one. You'll have to help me find an analogy. So do make sure to reach out. And remember, GraphQL and serverless, they have a very symbiotic relationship. They do not depend on each other, but they make each other look great. So go build something for yourself using GraphQL and serverless right now. Thank you so much.